Welcome to IOQM 2025 solution to the paper. This is for the region 4 and 5, the second paper which was conducted in this year. Okay, so we are going to cover in this video all the 3 marks questions, that is from 11 to 20. Okay, so let's do it. Let m be a positive integer satisfying the equation 5 times 2m plus 1 into 2m plus 3 into 2m plus 5 equal to AB, 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 where A and B are represented different digits and AB, AB, AB is a 6-digit number. What is the value of m plus A plus B? Okay, so similar problem came in the first paper also actually. So it's the same way we will solve. Okay, AB, 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 we can write it as 100 10,000 times AB plus 100 times AB plus AB, okay, which is nothing but 10,101 AB. And 10,101, if you factorize, you get a very simple factorization actually. 3 into 7 into 13 into 37, all are primes here, okay. So this is the prime factorization into AB, okay. Now this is equal to my 5 times 2m plus 1 into 2m plus 3 into 2m plus 5, okay. Now if you see the LHS side, you have 3 odd numbers, 3 consecutive odd numbers actually. Okay, these are 3 consecutive odd numbers, 2m plus 1, 2m plus 3 and 2m plus 5 into 5. Here, you try to adjust the existing numbers at least close to some consecutive odd numbers, okay. So, you get something like AB into 7 into 37 into 39. So, AB into 7 should be either 35 into 5 because there is a 5 also here, correct? Or 41 into 5. There are only two options, right? So 7AB should be either 5 into 41 or 35 into 5. So take case by case. Case 1, 7AB equal to 5 into 41. So in this case, AB, you don't get any integral solution actually. So this is not a possible solution. This is not the possible solution. Case 2, 7AB equal to 5 into 35. In this case, AB is equal to 25. So which means A equal to 2, B equal to 5. Okay. So now this is a possible solution. Now if you take A and B as 25, substitute into the main equation, you will get 2m plus 1 equal to 35 or m is equal to 17. So my m plus a plus b is nothing but 24. Okay. Little lengthy, but I think easy to solve, right? Moderate, I would say. Yeah. Next. Find the number of ordered pairs m comma n where m and n are positive integers less than or equal to 20,000 such that m square plus n power 4 is the power of 2. Okay, for yeah, this problem you need to understand one simple concept actually. Then it is very easy. Otherwise, it's a bit difficult. Okay, so m square plus n to the power of 4 equal to 2 to the power of k. That's what is given. Power of 2, right? So which means how do you represent 2 power k as sum of two numbers? Is it possible? First thing. Okay, you take any 2 power k and uh, try to sum it up with two squares or one square and one to the power of 4. Okay, so it's not possible. Only option possible is 2 to the power of k can be written as sum of two squares in only one way, that is both are equal. Okay, 2 to the power of k minus 1 plus 2 to the power of k minus 1, which is equal to 2 times 2 to the power of k minus 1, that is 2 to the power of k, right? So this is the only way you can represent 2 to the power of k in sum of two numbers. Okay, so which means my m square and n to the power of 4 are equal, correct? So now you just make a table. It's a counting problem. Okay, simple counting method. So you take your m. Okay, you take the m square value of it, you take the n to the power of 4 value of it, then what is the 2 to the power of k? Okay, so for m equal to 1, m square is 1, n equal to 1, n square also, n to the power of 4 also 1, so 2 to the power of 1, which is 2, sum of this m square plus n to the power of 4. Similarly, start taking 4, okay, and what is the maximum we can go? Up to 20,000. So, this is where you will stop. Basically, after 1, 2, 2 square, 2 to the power of 4 square, okay, because here this is where I am making my 2 to the power of k, 1 2 4 8 16 32 64 and 128, and this is square of this one, okay. 2 square 4, 4 square 16, 8 square 64, 16 square 256, 32 square 1024, 64 square 1000 4096, and 128 square is here. Okay, now I am not interested in the summation of it because I know that you are going to get 2 to the power of k anyway. And just for your information, I'm showing it here. What I'm interested is n values and m values. Okay, and how many ordered pairs are there? 8 basically. M comma n ordered pairs are 8. So how many, the number of ordered pairs is what is asked, is 8. That's the answer. Okay. So yeah, this I would say hard for a 3 marks question actually. Just because you should know the concept of 2 power k and then make this table, right? So for the 3 marks questions, definitely it is hard. Okay, next. In a convex quadrilateral ABCD, the lengths of diagonals are 12 and 16, and the line segments joining the midpoints of opposite sides are equal length. What is the maximum possible area of quadrilateral ABCD? Okay, so yeah, this one just once you draw it, you will understand very easily actually. So there are three conditions. Okay, one is it is a convex quadrilateral. Okay, that means no angle is more than 90 degrees basically, right? Okay, no angle is more than 180 basically. Or okay, next lengths of diagonal are 12 and 16, which are different. That is another second part. Third one is so which means actually you cannot take rectangle and square, right? And the third condition is line joining the midpoints of opposite sides are equal. Okay. Now let's draw one convex quadrilateral here, something like this. Okay. Now this is a convex quadrilateral. Diagonals are different, so it can be 16 and 12 possible. But opposite sides, if you add them, do you think they will be same length? Yeah, that is not. Okay. It is possible only in the case of kite. Okay, so kite is the only possibility where you have opposite sides, midpoints of opposite sides. If you add, draw a line, basically both are equal, and then diagonals are of different length. Okay, and of course, rhombus is a special case of kite where all four sides are same. That's all. Okay, but in both cases, what is the area of kite or rhombus? It is a square of product of diagonals divided by two. Right, so my area of kite or rhombus is product of diagonals divided by 2, which is nothing but in this case 12 into 16 by 2, which is 96. Okay, that is the uh, maximum possible area of ABCD, quadrilateral ABCD. Okay, so it's just a geometry question actually. If you know, it is easy, otherwise slightly difficult. Okay, next. The side AB of a square ABCD is 1 and it is also a chord of a circle S. The side CD does not intersect S. The length of the tangent CK drawn from C to S at the point K is 2. Okay. The tangent length is basically 2, more than the side of the square. Okay. If the D is the diameter of the circle S, then calculate the D square. Okay. So first draw the diagram. Okay. This is one way. You have a circle drawn where one of the side of the square is a chord basically. Okay. And can you have this square inside the circle? Then you cannot draw a tangent first thing. Okay. Now I can draw a tangent from here. I can draw a tangent, and this length of tangent is more than the side, right? 2. Side is 1, tangent is 2. So if I draw a picture like this, I will get a tangent to this circle which is more than side, and so this is a possible one. Okay, if I draw something like this, then my tangent from C to here, okay, tangent from my C to the circle is less than the side, so it cannot be like this. It has to be more than half up. Okay, square should be more than half upside. Okay, this is the only possibility. Now let's draw the diagram on this one. Okay, so this is the center of the circle. OA and OK are the radius. At K, I have a tangent from C. So this is 90 degrees. And I'm drawing a line from O to Y, which is a perpendicular here, right? And divides it into two halves. Okay, because AB and CD, okay, this is D, CD, both are parallel chords actually. AB is a chord to this circle, and OY is extended, it will become diameter, so radius, it will definitely uh, perpendicular bisector of AB basically called. Okay, so it is same. DC is also parallel to AB, so this is also midpoint. Okay, now we have triangles, you have to apply triangle rules, right? So in OYC, which is OYC? OYC, this is the right angle triangle. Okay, so CY square equal to CY square plus OY square equal to OC square. CY is nothing but CY is half because the side of the square is 1, so this is half. So 1 by 4 plus OX plus 1. Okay, which is OX plus 1 here? I have OX plus 1. XY is 1. Excuse me. Equal to OC square. Okay. Now, second equation is in triangle OKC. Okay. OKC also, this is 90 degrees here. Tangent and radius are at 90 degrees to each other. So, OC square equal to R. If I say OK is R square plus 4. Okay. Because tangent is given as 2. Okay. Next. In OXA, okay, this is also rectangle triangle here, and OA is R. Okay, So OX square plus AX square equal to OA square. That means OX square plus AX is half, right? So 1 by 4 equal to R square. Now from these three equations, okay, I can derive, if let's call OX as n, then I can derive the summarize basically n square plus 4 plus 1 by 4 equal to 1 by 4 plus n plus 1 whole square. Okay. Now, if I expand it and cancel, I get my value of n 4 equal to 2n plus 1. This is the simplified equation of above, which means n, which is OX, is 3 by 2. So my R square is nothing but 9 by 4 plus 1 by 4, which is 5 by 2. And I am looking at D square, right? D square is nothing but 4R square, which is 10. That's the answer. Okay. Next. Yeah, this is moderate, I would say. Okay. If ABCD are positive integers such that 17 times ABCD plus AB plus AD plus CD plus 1 equal to 20 times BCD plus B plus D, find A square plus B square plus C square plus D square. Similar problem came in paper 1, but this is little bit extended, little bit more writing you have to do in this case. Okay, more number of cases you have to solve. Okay. 17 times ABCD plus AB plus AD plus CD plus 1 equal to 20 times BCD plus B plus D. Now look at, is there a BCD, B, D is there and A is common. So take A common, okay. So it will become 17A times BCD plus B plus D plus 17 times CD plus 1 equal to 20 times BCD plus B plus D. If I simplify it, what it will become is 17 times CD plus 1 equal to, okay, uh, BCD plus B plus D into 20 minus 17A. Okay, this is what it will become. Okay, now you understand the LHS side. This is all positive integers. ABCD are all positive integers. So 17 is positive number, CD plus 1 is positive number, BCD plus B plus D is positive number. So 20 minus 17A should be positive number, right? So 20 minus 17A is positive, okay, greater than 0, which means A is less than 20 by 17. So only possible option for A is 1. Okay. A is less than 1 point something, right? Which means A has to be 1. It cannot be 0 because it's a positive integer. Okay. Now you got A, substitute it in the above equation and simplify it. Now I am left with 17 CD plus 1 equal to 3 times BCD plus B plus D. Now again look for CD plus 1. Okay. There is a CD plus 1 if I take B common here. Okay. So that's what I did here. 3B times CD plus 1 plus 3D. Okay. Now similar way above whatever I did, same way I will simplify it. So this will become CD plus 1 into 17 minus 3B equal to 3D. Now CD is positive, 3D is positive. So obviously 17 minus 3B should be positive. Correct? 17 minus 3B is greater than 0, which means B should be less than 17 by 3. In this case, I have 5 options for B. 1, 2, 3, 4, 5. All 5 are possible. Okay. Now check case by case. That's it. Okay. So this is what B is 1, 2, 3, 4, 5. So check case 1, which is B equal to 1. So in this case, I am left with 14 times CD plus 1 equal to 3D, or 14 times D minus 3 minus 14C. Okay, 3 minus 14C can never be positive, right? Even if you take minimum value C as 1, this is still negative value, right? So there is no solution for B equal to 1. Similarly, B equal to 2, there is no solution because 3 minus 11C cannot be positive with minimum value also. B equal to 3, similar logic, no solution. B equal to 4, similar logic, no solution. Okay. Once only with one value, that is B equal to 5, you get a solution. Okay, in this case, 2 times CD plus 1 equal to 3D, which means 2 equal to D times 3 minus 2C. Okay, for 3 minus 2B to be positive, C can be 1, right? C, the 1 is the only option. So C is equal to 1. Okay. Now, once you know the value of C, you substitute in any of the equation here. So you will get D plus 1 equal to into 2 equal to 3D, which is D equal to 2. Now I have my A, B, C, D. All values are there. Okay. A equal to 1, B equal to 5, C equal to 1, D equal to 2. So my A square plus B square plus C square plus D square equal to 31. Okay. That's the answer. Yeah. Next. Yeah, this is moderate. It is lengthy, but I think you can solve it easily. It's a simple number theory, right? Next. Yeah, 16th question. Yeah, it looks very big, but it's very simple actually. You have a fraction written in the form of 1 minus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7. This is equal to the another fraction which is written in 1 by x1 plus 1 by x2 plus 1 by up to x6 plus 1 by x7. Okay, now where x1 to x7 are positive integers, what is the sum of all xi's? Okay, x1 to x7, what is the sum? Actually, this is very simple problem. We should know how to solve it. Okay, take 6 plus 1 by 7 here. Okay, this is nothing but 42 plus 1, 43 by 7. So 43, 7 will become reverse, right? 7 by 43 it will become. Now again solve it, reverse it. Again solve it, reverse it. You get a value on the LHS side. Okay, that value on LHS side is 3946 divided by 6961. Okay, this is my value. Okay, now once I know this one, I need to rearrange it in the form of RHS side. Okay, so how do you do that? You now come from top to bottom. Okay, in the LHS side, you went bottom to top. Now you come top to bottom. Okay, how you do this is very simple. This is what your LHS. So I will write it as 1 by 6961 divided by 3946. Okay, I can write this denominator as 1 plus 3015 divided by 3946. Okay, and which is again I will write it as 1 plus and reverse it. Okay, reciprocal I take, and then again write this reciprocal 3946 in 1 plus 931 by 3015. Now again this one I will take reciprocal and write it as 3 plus 222 divided by 931. Again this I take it as reciprocal and write it as 4 plus 43 by T2. So similarly keep doing it. This is what the finally fraction you get: 1 by 1 plus 1 by 1 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7. Now these are all my x1 to x7s. Okay, x1 to x7s are here. Okay, so sum of all this is 27. That is the answer. Okay, I think this is easy to moderate. I would say easy, but it's okay. You have to do patiently without making a single mistake in the fraction. So it's a moderate. Next. There are 100 cards in a box which are numbered from 1 to 100. While being blindfolded, Mainak is going to draw one or more cards from the box. After that, he will remove his blindfold and multiply together the numbers on these cards. Mainak wants the product of the numbers on the card drawn to be a multiple of 6. How many cards does he need to draw to make sure that this will happen? Okay. The question is basically you have 100 cards numbered from 1 to 100. Okay. Okay. You randomly draw n number of cards from that 1 to 100, and what is the minimum number of cards I should draw to make sure that I get a product of a multiple of 6. Okay, which means I should draw n minus 1 cards whose product is not multiple of 6, then draw the last card which makes it product of 6. That is my nth card. That is what n is the answer. Okay, nth card is the answer basically. Okay, so how do we do this? Basically, this is a prime factorization method. Okay, so 6 multiples should have 2's and 3's as factors. So a 6 multiple is in the form of 2 to the power of p into 3 to the power of q into k. Okay, and p and q should be minimum 1. Okay, positive integers. Okay, so from 1 to 100, number of integers divisible only by 2, not by 3, are 50 are divisible by 2 and 16 are divisible by 6. So I am subtracting them. Okay, 16 into 6 is 96, right? And 50 into 2 is 100. So from 1 to 100, I have 50 minus 16, that is 34 numbers which are only divisible by 2. Similarly, number of integers only divisible by 3, not by 2, are 33 minus 16, which is 17. Okay, number of integers divisible by only 6 is 16. Okay, I mean 16, not only 6. They are definitely divisible by 2 and 3 also. Okay. Other numbers which are co-primes with 6 are 33. Now, just see, if I draw all these 33 cards first, still the product is not a multiple of 6. Okay. And then what is the next biggest number? Is this one 34. So I draw all 34 cards. Still the product is not multiple of 6. So how many is total? 67 cards I have drew, and no, it is not a product of 6 yet. Next card if I draw either from 3 or 6 multiple. Okay, which makes this product as a multiple of 6. So 67 plus 1, that is 68 cards I have to minimum draw to make sure that I get a product of 6. Hope you understand this explanation. Very simple problem. Okay, just you have to think a lot. Okay, it's all about number theory, right? So it's a moderate. Yeah, next. Yeah, this problem, let me explain first and then I'll solve it. In the plane, let the positive end of x-axis be directed towards east and the positive end of y-axis directed towards north, as x and y-axis normally represented. Suppose you are at 0, 0 and you want to go to 7, 12. At every move, you are allowed to move unit length towards east or north. Means either you can go to the right or you can go to the up. Okay. Your current position from your current position. But you are not allowed to visit any point h, k where h and k both are odd. Okay. Find a number of such paths n. Okay, so this is a very simple grid counting problem. Only thing is he added one extra condition where some of the nodes you cannot go actually. Okay, so if you mark them red and just do a grid counting, you will get the answer. Okay, let's try it on 7 by 10, simple one. Okay, this is my 7 by 10 grid, and where I cannot go, all the odd. Okay, if h comma k both are odd, I cannot go. That is, these are the points. Okay, these red points I cannot go. Okay, this is 1 comma 1, 1 comma 3, 1 comma 5, 1 comma 7, 1 comma 9. Similarly, this is 3 comma 1, 3 comma 5. Okay, 3 comma 9, and so on. Okay, so these are all places I can go from 0 comma 0 in only one way. Okay, one way, one way, one way. There is no other way because I cannot from here. I cannot go and come back, come down here, right? Okay, south is not allowed. I can go only east and north. Okay, only right and up I can go. Okay, I can only it's like a staircase. I can only go up. Okay, I cannot come down. Now this position I can go in one way only because this is in between these two red spots. This is also one. So let's see another ones. These are all also ones. Okay, I can go only in one way. But this part is there, I can go in two ways, right? This is what the grid counting method. Okay, this part I can come in one way, one way. Okay, that is from here this way or from here this way. Two ways I can come here. So how I am get the two? 1 plus 1, that is 2. Okay, this is what the grid counting method is. So every grid you have to do like this. So these are all my twos. Okay, and this is also 2 because both sides red is there. There is only way I can go here is only from here. Okay, but this part I can come in 2 plus 1, which is 3 ways. Okay, this part also can come in 3 ways, and this is also 3. Okay, this is also 3. So let's put 3s. These are 3s. This is my 4. Okay, of course this is also 3. I did not put it here. Okay, I just want to show you how to do the grid counting method. That's all. Okay, so this is my 4s, this is my 5s, this is my 6. Okay, and look at the 6 is here also. 3 plus 3, 6. Okay, now this is my 10 because 6 plus 4, 10. See how the number is increasing, right? And now next is this is my 15. Okay, this is my 20 here. Okay, this is my 21, 15 plus 6. This is my 35. This is my 56. So this is also 56. Okay. Now I just did this for 7 by 10. You have to do for 7 by 12. Okay. So for a 7 by 12 grid, you will get 28 more. Okay. 28 plus 56, which is 84. Okay. This is the answer. If you are doing for the first time, it is very difficult, definitely. But similar problems came in Olympiad, of course, without the red dots. Okay, so it should be possible. I have seen similar problems in Singapore Olympiad also. Okay, should be possible. Definitely hard for a 3 marks question, but there is a easy method to do. Okay, using if you are good in permutations and combinations, there is a easy method to do it. Let's do again same problem with the permutations and combinations. Okay, okay. So this is my 7 by 12 grid exactly. Okay, and how can I come to 7 by 12? I have to come to 6 by 12 first, then come here, right? So my number of ways I can come to 7 by 12 is equal to number of ways I can come to 6 by 12. Both are same basically because from here only one way I can go. So into 1, which is same basically, right? So to go to 7 comma 12, first go to 6 comma 12 and then go to 7 comma 12. So number of ways to reaching 7 12 is nothing but number of ways to 6 12 into 1, which is same. Now how many ways to reach 612 is the same as reaching 3 comma 6 without any red dots. What is the meaning of this one? If you understand this one, if I consider instead of considering this as 1 square, if I consider this as 1 square, okay, now this is my 1 comma 1, okay, because I can only come in same number of ways 1 1, this is 1, okay, this is right 1 1, this is 1, okay. I can come in two ways, but if I consider this as half basically, okay, so this is my 1 comma 1. Okay, I can come in two ways, correct? This part I can come in two ways, either this way or this way. If this is 1 comma 1, this is 2 comma 2, this is 3 comma 3, this is 3 comma 4, 3 comma 5, 3 comma 6. So this 612 will become grid, will become half of it. If I consider 4 squares as 1 square, okay, 4 squares as 1 grid, this will become half, 3 comma 6, correct? Now once you know if it is 3 comma 6, if you know the permutations and combinations, this is the grid of 3 comma 6. How can I go from 0 comma 0 to 3 comma 6? In 3 plus 6 C3, 3 plus 6 C3 ways I can go. Okay, either you can take C3 or C6, both are same. So this is nothing but 9C3 or 9C6, both are same, which is 84. Okay, so using permutations and combinations, this is very easy problem actually. I would just still say moderate because there are 8th class and 9th class students attending same paper. For them it is definitely hard actually, not even moderate, but I'll say moderate if you solve it using permutations and combinations. Okay, next. 19th question. Find the number of ordered pairs m comma n where m and n are positive integers such that 1 is less than or equal to m, less than n, less than or equal to 50, and the product of mn is a perfect square. Okay, see the condition carefully. M and n are between 1 and 50 inclusive, but m is less than n means m and n cannot be equal. Okay, that is the important condition here. Once you know this condition clearly, this is a good problem, but can be solvable. Okay, so every number can be expressed in kx square form, correct? You have some square part. Okay, if there is no square part, like if you take 3, 3 can be expressed as 3 into 1 square, right? So similarly, every number, okay, you take 8, 8 can be expressed as 2 into 2 square. Okay, so once you know this one, m is equal to rx square, n is equal to sy square. Okay, because this is square, sorry, this is not 2, this is square. Okay, once you know this simple logic, mn is equal to rs into xy whole square. Okay, so mn should be a perfect square. What is the condition then? Rs should be a perfect square, right? So Rs should be a square, which is k square. Okay, which means here k is a square free number. Okay, k square is a square, but k is a k square free number. If k includes a square, something like 12, if I take 12 can be written as 3 into 4, correct? K cannot be 12 because the 2 square part is taken care in the x square and y square. Okay, so now you make a simple counting, okay, for the k. K can be 1, 2, 3, cannot be 4, okay, 5, 6, 7, okay, cannot be 8, 9, 10, 11, 13, like that. Okay, and k cannot be equal to these numbers. Okay, cannot be 9 also, sorry, right? Right, so this k is not possible for this one. Now once you know, come to this stage, make a simple table, you will understand the problem very easily and you can solve it. Okay, what are my k values here? Okay, corresponding m values, n values, and how many are possible combinations, mn. Okay, so let's take k equal to 1. Then if I take k as 1, right, k square, then mn, right? Mn can be any perfect square from 1 to 50. So all the perfect squares here I am listing 1, 4, 9, 16, 25, 36, 49. Anything can be m, anything can be n. But since we know that we cannot pick, it cannot be 7 into 7 possibilities because m is less than n. This is important condition. That's why I said. So 7C2 are the possible combinations, which is 21. Okay, I can make 21 ways m and n from this list if k is equal to 1. If k equal to 2, then k square is 4, correct? Then my m can become 1, 4, 9, 16, and 25. Okay, because uh, 49 into 2 will become more than 50, correct? So it is not a possible number. 25 is possible. 25 into 2 is 50. 50 is inclusive basically. M and n can be 50 actually, right? So n also can be same. Now I have to pick again 2. So 5C2 ways I can pick, which is 10. If k equal to 3, then 1, 4, 9, 16 are possible ways. 16 to 3 is 48. This is the max I can stop it. So 4C2 ways, which is 6. Then 4 is not possible for k because 4 is 2 square, which is already covered in this one, right? One of the two squares. Okay. So 5, then 3 possibilities are there. 6, there is only one possibility. Okay. Because 1 comma 4, 7 is 1 comma 4 only possible. Okay. Uh, if I take next one, which is 9, 9 into 7 is 63, more than 50. So I cannot. So this is up to 11 I can count. Okay. Then after 13, there is only one possibility, which is 1. And with 1, it is not possible because m equal to n it will become. I cannot take m equal to n, right? M is less than n. So both cannot be same number. Okay. So up to 11 I can count, and after that there is no other possibility because it will be same as 13. Okay. So how many total are there? 21 plus 20 plus 6 plus 3 plus 4. Okay. That is 44 possibilities are there. Okay. Problem looks simple, little complex actually. For a 3 marks question, it is hard. Okay. So we can see actually in this paper, you are finding already hard problems in 3 marks questions itself. So this paper definitely looks tougher compared to the first set of papers which came in September 8th. Okay. Okay. 20th question. How many 4-digit numbers ABCD with non-zero digits A, comma, B, comma, C, comma, D in base 10 are there such that A plus C equal to BD and B plus D equal to AC? Okay. What is trying to tell is ABCD are digits actually. Okay. And how many 4-digit numbers ABCD are possible in base 10 such that first digit and third digit is equal to sum of first and third is equal to product of second and fourth, and sum of second and fourth is equal to product of third and fourth digits. Okay. So this is also definitely a simple counting problem. You have to just make a table and clearly write what are the conditions basically, right? So max of B plus D is B can be 9, D can be 9. So digits, right? B and D are digits. So max of B plus D is 18, which means B plus D is nothing but AC. So AC should be less than or equal to 18. Okay. Similarly, A plus C is 18, so BD should be less than or equal to 18. Now, these conditions is what we need to check carefully. So, what is my AC? What is my B plus D, which is nothing but AC? Then BD, my AC, A plus C. Then you form the number which is possible here. So, let's take AC as 1. Okay. If A and C 1 1, so AC can be 1, but B plus D cannot be 1. Okay, because they are only positive non-zero digits, right? They are non-zero digits, and digits cannot be negative, right? So all that if you consider, B cannot be 0 and 1 is the only option, which is not possible here. Okay, so now you take AC equal to 2. If AC equal to 2, B plus D can be 1 comma 1 because 1 plus 1 is 2. Okay, in that case BD is equal to 1. If BD is equal to 1, I cannot form AC. Correct? AC has to be A plus C has to be 1, which means 0 plus 1, and 0 is not a possible value, non-zero digit. Okay, so no possibility. 3. AC equal to 3 if I take, I have B comma D possibilities are 1 comma 2 and 2 comma 1. Okay, and BD should be equal to 1 into 2 or 2 into 1, which is both ways it is 2. Okay, now my AC should be 1 comma 1. Okay, in that case 1 plus 1 should be equal to BD, right? 1 plus 1, which is A. This is my AC values. Okay. So 1 plus 1 will be equal to 2, but BD is equal to 1 plus 1 is not equal to 2. Sorry, 1 plus 1 is not equal to AC, which is 3. It should be 3 actually. So it's not possible. Okay. Here. So this is also not a possible solution. Similarly, you start counting this way, you will get a possible solution at 2 comma 2. Okay. When it is 2 comma 2, when AC equal to 4, I have options 1 comma 3, 2 comma 2, and 1 3 comma 1. So in this one, for 1 comma 3, BD is 3, and 3 comma 1 also BD is 3, but 2 comma 2, BD is 2, 4. So in this case, I can get my AC as 2 comma 2. My number is 2 comma 2 comma 2 comma 2. Sorry, 2222, 2222. Okay. Now for 5, AC equal to 5, 2 comma 3 I get. Here also I get a possible solution because 2 comma 3 if I take, okay, my B plus D is 2 comma 3. Okay, if B plus D is 2 comma 3, BD is 6. Okay, if BD is 6, I can have my AC as 1 comma 5. Okay, and 1 comma 5 is basically 1 into 5, which is equal to 5. So it is possible solution. Okay, so in this case, my options are I get my BD is 2 3. Okay, B comma D or 3 comma 2 also possible, right? Reverse also possible, right? So 2 3 3 2 3 2 BDs, okay, exchanged. And what are my AC? 1 5 or 5 1. So 1 5 1 5 5 1 5 1. So totally I can make 4 numbers. Okay, similarly reverse, if my BD is 1 comma 5, then AC is 2 comma 3, then I again make 4 numbers, and you can start making this table, continue with this table. As you go higher numbers of AC, you will not get any possible combinations, and as you understand the products and multiplications will result in a bigger number, so definitely these are not a possible solutions. You can try for 7, 8 and you can leave it because you will understand that products are very high numbers you get. Okay, which is like impossible combinations after this. Okay, so total possible combinations in this case are uh, 9 basically. Okay, if you see here 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 possible combinations. No other solution is possible. So 0, 9 is the answer. You have to write 0, 9 in the 2-digit form actually. Okay, this is definitely hard for a 3 marks question. So it involves a lot of understanding actually of number theory. Okay, and this is also definitely hard. So all the 3 marks questions are done. I think we have seen a lot of hard problems already. So let's see how the 5 marks questions will be. Okay, and yeah, this video ends here. Next video, I'll make 5 marks questions for the region 4 and 5 IOQM 2025. Till then, keep doing maths. Thank you.